So welcome back. Today we are going to look something on linear differential equation, and our question is solve the following linear differential equation. Now our first question is x times y prime plus 4y equals to x power 5, and you know that the standard form of a linear differential equation is given by y prime plus px of y is equals to q of x. So you should just identify that is this our equation, is it in this form, so that we can able to solve it with ease. So when you look at our question is xy prime plus 4y equals to x power 5. So when you look at this question, automatically it is not in this form, in the standard form of the equation. So we will make it be in a standard form by dividing here by x, dividing by x, so that I'll have my y prime equals to 4 over x multiplied by y times, not times, but here is plus, sorry, is equals to x power 4. Then from here we are going to identify our p of x, we identify our q of x, and then we'll find our integrating factor. So our p of x is given by 4 over x. So our p of x will be given by 4 over x, and our q of x is going to be given by x of 4, as you can just see it in our standard form. So we know that from at this point now we find our integrating factor. Let me call it I of x, and our I of x now will be given by the integrating factor of a linear differential equation is given by exponential e raised to the integral of px dx, and our px in this particular form is just e raised to px. Our px is 4 over x with respect to dx, the integral of it. So here we know that the integral of this whole thing is just the same as e ln x to the 4, which is that the same as x to the 4. Then we are going to find our y. I'm going to find our y, and I'm going to give out a formula that can easily be used to solve it. So y is given by 1 over integral factor into the integral of q of x multiplied by integral factor dx plus some constant c. So in our case it will be y equals to 1 over the integral factor, and our integrating factor is 4 into q of x, and my q of x you can see is x raised to 4 times integrating factor, which is x raised to 4 dx plus some constant c, integrating factor here, some plus some constancy. So I'll have y equals to 1 over x to 4 into 1 over x to 4. So whenever I multiply the whole thing here is x raised to 8 dx plus c. Then you will see that this is the same as y is the same as 1 over 4, 1 over x to the 4 into the integral of x to 8 is 1 over 9x to 9 plus some constant c. So this is just the same as saying y is equals to, so when I open this bracket, it's just the same as 1 over 9x to 4, 1 over 9 not to 4 but 1 over 9x to 5 plus c over x to 4. So we can write this one in standard form and say that this is the same as y is the same as 1 over 9x to 5 plus c x power negative 4. And my research tells me that this is the way it should be done. Thank you. So our next example is y prime minus 2xy is equals to x. So you can put on a pause and try. So I say that the standard form is just in the form y prime plus pxy is equals to some to q of x. So you will realize that by looking at this one and the standard form of it, you will just see that it is in the form. And we know that to find our integrating factor, I'll call it ix, we find it by using exponential e raised to p of x dx. And here we have e raised to p of x. Sorry, we never named the constant. So our p of x from that particular point, our p of x is negative 2x. As you can see here, the correspondence of x is negative 2x. And then our q of x is x. So for us to find the integrating factor, we say that integrating factor is given by e raised to px dx. Then we'll now integrate px with respect to dx, and our px is negative 2x. Multiply it by dx. This is the same as e raised to negative x squared. then we know that for us to find our y, the equation we're interested in, is just the same as 1 over integrating factor of x into the integrating factor of qx, integrating factor of x, multiply it by dx plus some constant c. So you'll realize that this is the same as 1 over the integrating factor, which is ex squared, into integral of qx. My qx, you can see, is x multiplied by the integrating factor, which is e raised to negative x squared dx plus some constant c. So you realize that this is the same as y is equals to 1 e negative x squared into the integral of x e negative x squared dx plus c. So we want to integrate this part. So the integral of x e negative x squared dx is just the same as, I'll use u substitution. So you'll realize that I have x e u multiplied by du over the integral of that. The other part is 2 negative 2x. So x will cancel. I'll bring out negative a half. So I'll have negative a half the integral of e to u, which is just the same as negative a half e. I'll bring up my u, which was negative x squared. So everything I have here is the same as the other one. So I'll just say that my y now will be given by 1 over e to negative x squared into negative a half e negative x squared plus c, which is a constant this particular point. So this is the same as y is equals to, you know, that when I open this bracket, I'll have negative a half plus, then whenever I multiply this, the same as c over this, which I can just write as c e x squared. Thank you. And this is what our research tells us is the answer. Thank you.